Guys, you guys are pretty familiar with that for 103. Coil voltage rating for the relay. Okay. Coil voltage reading is written on the sticker right here. Coil is 24 volts. Okay. Now, I want to know what the resistance of the coil is. Okay. We know that the coil starts here, copper wire runs all the way through, spins around a couple thousand times, comes around on the other side, creates a coil. So these are our coil terminals. On the relay itself, 1, 2, and 3. 1 and 2 are normally closed. 1 and 3 are open. 4 and 5 are closed. 4 and 6 are open. When we energize the coil, it reverses. 1 and 2 open, 1 and 3 close. 4 and 5 open, 4 and 6 close. Okay? But we got to check the resistance of our coil. Now I know our meter's off by 0.3 ohms of resistance, but we're going to zero it out anyways. 0.3 ohms. We're going to go 0.3. Alright? So what we're going to do is we're going to check the resistance of the coil.
Come share with me.
17.3 ohms it said.
Yeah, we gotta subtract 3.
And how much would it be? 17 ohms of resistance. So that was what we would write down. Is the coil open, shorted, or good? It's good. Okay. Now it says, what is the contact resistance when the coil is energized? So what we're going to do is we're going to energize that coil. This here is 24 volts. It says right there. 120 volts are connected here. 208 volts are connected here. Okay? To get the voltage and the power to run to these individual boxes, what you're going to do is you're going to energize by pulling emergency stop out. Light is red. Hit the blue button. Sends power through and sends power to all the individual circuits. But you need to turn the switches on individually to apply the voltage to the device you're working on. If something's to go wrong, just hit it. It kills everything. That's what emergency stop is for. Okay? All right. Now, I need to apply 24 volts to this coil. So, switch is off. Okay? Now, watch this, guys. Go ahead. Turn it off. Hear it click? Yes. Alright. So, now, let's watch this. 1 and 3. Let's check 1 and 3. Oh well. Hit that switch. 0.4 ohms, so it's like 0.1, okay? So what you would then write down would be 0.1 ohms of resistance.
Good.
Now, are these contacts burned, pitted, or good?
Good.
Good. Physical construction?
Good.
Good. Or okay. All right? Done. Relays. Or contactors next. Check it out, guys. This contact here has got a 24 volt coil because it tells me right there. This one here has got a 120 volt coil because Adriano wrote it right there. Okay? Let's go with this one here. You can pick any contact, I don't care. Alright, now, what we're going to do is we're going to apply 120 volts to the coil. It'll energize the contacts. By doing that, we're going to take this here, 120 volts. You got a positive on one side, and you have a neutral for the other side. The green, all right, you got to put it around your finger. All right?
That would be.
You can't even be touching that how you are right now if that thing is on.
You just touch it, you just put it to the chassis. That's all you're going to do. Okay? All right, now, what we're going to do now is, okay, we already checked the coil. Did we check the coil voltage yet or no?
No.
Well, what we said it was 120 volts.
Yeah.
We didn't check the resistance. Let's check the resistance.
So do we have to check the voltage? Because we already know what it is.
You already know what it is.
Yeah,
It's 120 volts. You just got to look at it and
Oh,
write
okay.
it down. You're not checking the voltage. Just write down what you see. So the resistance of this coil here is... Come on. It's all over the map. Let's just say it's 181.3 ohms of resistance. So in reality, what is it?
Good.
No, how many ohms of resistance? It's 181.3.
Oh, 180.
180 because our meter's off by 0.3.
Yeah.
Okay? Very good. All right, now, okay, coil condition, is it good? Yeah,
Yeah.
it could be. All right, now, do me a favor, turn the power on for the 120 volt coil. Okay, now the contacts are now energized, or now closed, so now we can read resistance across the contacts. Okay, let's see what we get with you guys. All right, now, so what I'm going to do is I'm going to measure across all three. All right, I'm measuring here. This one's reading about 1.1 ohms of resistance. Good or bad? What should it be?
Under 5.
Under 5. Let's take a look at this
Wait,
one.
what did you say it was?
It's 1.1.
It's over 5.
Yeah, over 0.5. I thought he said 0.1.
This one here,
You can hear it shaking.
it's not even closed. Check it out.
You can hear it rattling, can't you? Am I
Yeah.
hearing shit?
Yeah.
No, you can.
You can hear.
Mike,
This one's not even closing.
bullshit. Throw it out.
It's funny because every group I've showed this on, it changes.
Really?
Yeah. This one here is 1.3 also.
So it's
The
bad.
first group is
So
all
it's
1.0.
That thing's
Last group, this one was closed. These two were open.
fried instead of
Okay, so is this good? Is this burn pitted or good?
Pitted, bad, horrible.
Pitted.
Get it out of there.
Pitted is correct. Okay, it's not good. It would be pitted. If it was burned, we would see actually like black debris, black
and you'd
soot
get, like, nothing.
around
It'd be
contacts.
open, right?
Exactly. Yeah, we'd see
Okay.
black. Yeah, we'd see black
Okay.
debris around it. But it's not making. It's not closing all three sets of the contacts. Okay, so it's got to be pitted. Thank you, sir.
Thank you.
Yep.
See you guys.
Yeah. So
Here. All right.
that would be fine.
So.
away.
So this
Visual,
visual
it's like
is
garbage.
is it worn or okay?
I'd say it's worn.
I'm saying it's garbage. Worn.
Warren is correct. But what I'm seeing is this, guys. It's all cracked right here.
Yeah.
It's cracked here. It should be level all the way across, all the way on all three of the contacts.
So the coil condition is
Coil
good?
condition,
Or
coil
is it-
condition is good. Coil works,
But
but the contacts are full
contacts are
rubber.
pitted. Okay.
Yeah, yeah, they're no good. Okay. All right. So we're done with that, right? All right. All right. Okay, we're done. Let's put this bad boy back. Next, start. All right, guys. This is the coil right here. 208, 220 volt coil it's got. Okay? These are the contacts. This is my auxiliary contactor. Remember I showed you in class that the contactors, or auxiliary contactors, usually hang on the side.
Yeah.
You can have one, two, it doesn't, whatever. This one here is actually wired in from these wires here. So when this closes, it sends the power through these wires here and closes it. Okay?
So what? How does it actually start?
We're going to energize the coil, and that's going to close the contacts between.
Like I'm just seeing this as a giant contactor.
You're exactly correct.
Why is it how it started?
Because of the way it's designed. Okay, it starts large commercial motors. L1 T1, L2 T2, L3 T3. L is the line side coming in, T is the tie-in. So we'd have our powers coming in through here, the big monster wires coming in. When this closes, it's going to send power out to the motor through the T terminals. That's the tie-in. Okay. Now let's look at our paperwork, guys. All right, motor starter, coil voltage is
208.
220. Coil resistance. Let's see what our resistance is of the coil. All right. You shouldn't really touch the ends because you can measure some resistance through your fingers, or your skin. 7 ohms. So it'd be what?
6.7.
6.7.
6.7 ohms of resistance. Okay. Is the coil open, shorted, or good?
Good.
It's good. All right, now we need to energize the coil and close the contacts. Hit the red button over there, if you would, please.
Hit the
Red button.
this?
Push it in.
Oh,
Thank you. All right, now we're gonna hook up our voltage to our coil.
Hey, why'd you turn that off?
Because I don't want to get electrocuted.
Oh.
yeah, it's not taking any chances, and that's
All right, I'm gonna hook the black wire to the black of the coil. Hit the red to the red. This has got 2 hots, guys. There's no neutrals. We're gonna take the ground and put it to the finger, put it to the chassis. Okay,
All right.
now,
What's this good?
all right, now, what we're gonna do is we're gonna energize the coil to close the L's to the T's. All right, where are you going?
He's scared.
I thought he was gonna go high.
I thought he was scared.
It's not on yet.
All right. So Fabian, you want to do the honors then, since somebody's scared over there? I guess all right. Hold on. Hold on. All right. Let me see you guys. Make sure you sit. Hit the blue.
Ay, con su puta
All right.
madre.
We had 3 guys jump. Last group we had none. First group we had 1. 3. Okay.
Yeah, I jumped.
All right.
You know
Yeah.
what? That's
That shit is loud. I didn't expect that. That's loud.
Okay.
Damn.
Now.
I have a motor at work that's like it's actually a weird voltage. It's like 440.
There's plus or minus differential. That's
But,
why.
yeah.
That's what it can operate at. If the voltage is to drop that low, it'll
They
be
had
fine.
that. We have a giant transformer that powers the thing, and we don't have a fucking massive
Check it out, guys. All right.
like that.
0.3 ohms of resistance. So we should measure some type of resistance between L3 and T3.
This is live, right?
Yeah, it's live. This ain't Memorex. 0.5, 0.4 ohms of resistance. Okay.
Where are you? Where's he?
I'm on L1 and I'm on L3, T3.
Oh, okay.
Okay. Now L2 to T2.
4, 3.
So we're good. L1 to T1.
I can't see it.
0.4 ohms of resistance. So it's 0.2 ohms of resistance.
Why are you
So-
forgetting we're off by 0.3? My
Yeah,
bad.
I know. It's okay. Okay, so are they burn, pitted, or good?
Good.
What's the physical view of the thing?
Good. Monster.
Okay. Okay. All right. Do me a favor. Hit that red button over there. Okay.
Oh, put your fingers in.
Yeah, I agree.
I'd watch a mouse. That's about it.
For a bug.